Hi, hello pre-calculus, and welcome to section 8.2 on ellipses, another one of the conic sections that we're going to deal with. And again, the ellipses are where a plane crosses through one of the conic sections at an angle, and will then end up making this ellipse form. If it goes through parallel to that base, then it's a circle, and that's a special type of an ellipse. But we're going to be focusing our attention on ellipses. And here's the definition. An ellipse is a set of all points in a plane whose distance from two fixed points. That's kind of the key thing, where the parabola was all this set of all points in a plane whose distance from a fixed point. But this is from two fixed points in the plane have a constant sum. So I've got a little picture up here that really kind of helps illustrate that. So when we look at this, it's kind of like putting two fixed points here. And those will be called each are a focus, or plural is foci of the ellipse. And if you kind of imagine taking this pencil and stretching that out, if there was like a little string connecting these 3 points, and then kind of rotating this around, that would make all these points here have a, as it says here, a constant sum, so that this this distance plus this distance is always going to be the same as we go around. So that's sort of what how we draw that ellipse, how it is actually constructed. Okay. So again, those fixed points are the foci. So again, that's what those points are right there, where those pins are. The line through the foci is the focal axis. So that line that goes through those 2 points is the focal axis. The point on the focal axis midway between the foci is the center. So again, we would find that center, halfway between those 2 points. And the points where the ellipse intersects its axes are the vertices. Again, if I draw just a quick little ellipse, we've got the focal axis that would go through. The points right here are the vertices of the ellipse. Okay, so we've got a little picture that'll help with that as well too. Okay, so again, that focal axis is that line that goes all the way through there. So there is actually a Pythagorean relationship if we look inside these ellipses, and that's kind of important, because if you know foci and endpoints, so if you know the foci is some c0 or negative c0, and the endpoint, the endpoints or the vertices here are a0, negative a0, or the other one, 0b and 0, negative b. If you know those different endpoints, whether they be actual vertices or not, you can always find the endpoints of the other axis. So this was kind of a neat little relationship. We'll see why we call this A and B in a second. But it does have a Pythagorean relationship here. So that hypotenuse is equal to a leg squared plus a leg squared, or in other words, our a squared in this situation is equal to our b squared plus c squared. So we'll talk about that. And again, I got it written over here as well too. This a is the hypotenuse, which is always the longest side. Okay. So let's kind of just move on. We'll show you how we use that here in just a second. We do have some, maybe I can get that back up here to match your pages here. So we got some notes that you can fill out in your paper. Our standard equation. Okay? Now remember, parabolas only have one squared term. our ellipses will have two squared terms. And this is how our standard equation will look, is that we have x squared over a squared plus y squared over b squared equals 1. We got to make sure it's equal to 1. That's going to be a key piece here, is that we have it equal to 1. Or we could have the b squared underneath the x squared. This is kind of the important difference between these two, is again knowing, going back up here, that our a value is our longest. Our a value is our longest. Our a is the biggest number. Okay? That, you notice here, it's underneath the x. So that means that our focal axis is the x-axis. So we'll have ellipses that'll look like this, that are elongated horizontally. Here, when our a value, the bigger value, is underneath the y, then our focal axis is on the y-axis. So that's where we'll have ellipses that are more vertically stretched this way. They're longer in the y direction than they are in the x direction. As we kind of figured out through the parabolas one, we can do a lot of this, finding the foci and finding the vertices, just by simply graphing and adding the pieces. But just to give you some information here, your foci are your plus or minus c0. Again, you kind of get that up here. You can see this here. It's either a c or a minus c for our foci. If it's going vertically, same idea, but now it's on the y part of the coordinate. So then we would have 0 and then plus or minus c. But you'll find out as we graph it, it's a little bit easier just to graph it and find those points rather than try to memorize, all these different templates. Same thing with the vertices. Vertices are at a and negative a0. So this would be at plus or minus a0, or if it's stretched vertically, it's at 0 plus or minus a. But again, graphing it will make it so much easier. The major, I'm going to say, look at this, major, that means versus minor. Major means the longer one. Minor one means the shorter one. Semi would be half. Okay, so if I look at this distance here, this is from 0, 0 to a0, that'd be a length of a. This would also be a length of a. So 2a is really the distance from one vertex to the other. The semi, or the half of that major axis, would be half of 2a, or just a. And that's the same argument here for the minor axis. If we look at the minor axis, that's the short one. The distance from the middle here up to here is b, which should also be the same distance here. So the distance of the minor axis is 2b. The semi minor axis, or the half of the minor axis, would be half of 2b, which is just b. And then we talked about that Pythagorean relationship. Again, remembering this a value is the longest. Okay, so just some basics, but I think it'll all make sense once we start getting into some of the problems and just kind of doing the work. I don't think you're going to have to memorize any of this. I think if you just do the work and graph it, you'll be able to find the other pieces. Just knowing, the definitions of these different pieces, what a vertex is, what a focus is, where the center is, and what a focal axis is. And again, I will just remind you, the major axis is the longer one, minor axis is the shorter one. Knowing that, should be able to get going on our problems. And we'll just try the first one here. All it's asking us to do is just graph this. Okay, so just graph this. So, I'm going to decide in this question, is this x squared over a squared or x squared over b squared? Excuse me. And we got to remember the longest one is always the a. So this one's bigger. So again, if we're looking at our general form of our equations up here, this has got to be some x squared over, and this is the smaller one, so that'd be the b squared plus y squared over a squared equals 1. So that's our form of this equation. I just want to draw that a little better. And so knowing this, again, the A is underneath the Y, so that's the longer one. So I know that this is going to be an ellipse that's elongated in the Y direction. It's got the major axis is going in the Y direction versus the minor axis on the X direction. So in working through this problem then, I'm going to look here and see that, okay, this is my B squared. Here's my B squared. So B squared is 100, which means then that my B value would be plus or minus 10. All right. Here, because that's the bigger one, that's my A squared value. So A would be plus or minus 12. Okay, so if I'm going to graph that, I'm going to graph this. These are all centered at 0, 0 for our center, because I don't see any adjustments to the X or to the Y inside here. We'll talk about that in the next page. So I do know then that my minor axis is 10 units to the right and 10 units to the left. So if I just count 5, 10, 5, 10, so this is negative 5, negative 10, 5, 10, so maybe 5, 10. Let's draw this up here. So maybe at 15, 5, 10, 15. So this is at negative 15 down here. So my minor axis is the B, so it's going out to 10, negative 10 and positive 10. And then the A is positive or minus 12, so I go up to 12. And we can then just do our best to sketch that ellipse. Again, not to worry about being too perfect. That's where our ellipse is going to look. So a little bit longer in the Y direction, 2 units longer than what it is in the X direction. So again, a little bit more elongated vertically than it is horizontally. Okay. Well, now we're going to get into actually doing some of the math work here to try to get our equations into that form, into that x squared over a squared plus y squared over b squared equals 1. Or again, these values, the a squared and b squared, could switch depending on which way it's been elongated. So we're going to try to get this into this form. So the first thing is, again, I always want to make sure that it's equal to 1. It is not. So what I'm going to do is I'm going to divide everything by 36. I'm going to divide this by 36, divide this by 36, divide this by 36. If I reduce that fraction, I would get x squared over 4 plus, that would reduce to y squared over 9 equals 1. So just as a side note, we're going to know that these are ellipses as well too when we look back at these forms. The x squared and the y squared have the same sign. They're both positive in this case. We can have a case too where we could factor out and be both negative. But again, that's how we know they're ellipses, is that they're the same sign. This is positive. This is a positive. That's positive x squared. That's positive y squared. So that's just a side note on how we also can recognize in the form that it's an ellipse. So now I've got this in the form I want, so I can graph it like I did this one over here. So let's graph it, because again, I think it's going to be easier rather than memorizing all those different templates to find the vertices and the foci. We'll be able to do that once we graph it. So now look at this. The y value, the one underneath the y, has the bigger value, so that's my a. Okay, so my a squared is 9, which gives me my a as plus or minus 3. Here, then, this is the smaller one. That's the b squared then, so that's 4. So b is then plus or minus 2. There's no adjustments to the x and the y. I know I'm centered at 0, 0. And I know then it's stretched more in the y direction. 1, 2, 3. 1, 2, 3. And only 2 in the x direction. So I know it's going up here, down here, here, in here. So there's roughly my um, ellipse. Okay, so then what I need to do is I need to find those vertices. Okay, well, so those are the vertices right here. They're the ones on the major axis. Okay, so they're right here and here. So that'd be at 0 and 3 and 0 and -3. All right. The foci. Okay. So this one we do kind of have to remember. The foci. If we go back up here, foci are those c values. Okay. So so we're looking for those. How far away those are. From the center. Right? So that's where we got to figure out what that C value is, because that we're going to have that foci somewhere inside here. Right? So I'm going to have to utilize that formula of a squared equals b squared plus c squared. So we got all these numbers over here. The a squared is 9, the b squared was 4. So subtract c squared. So c is plus or minus the square root of 5. So that's where those values are. So square root of 5 is a little over 2. So that foci would be right here. And the negative one would be a little bit over here. Okay. So our foci are at 0 in square root of 5 and 0 negative square root of 5. And so that's the only thing you really got to remember in terms of those formulas, is to be able to find that foci, and that's that distance right from here to here, is that C value. All right, let's give it another try with some other problems. So this one says find an equation of ellipse with a foci at -2, 0, and 2, 0. So this is where this is the foci are on those two coordinates. So I will just draw it up. So at -2, 0, is a foci there. And then at 2, 0, that's another foci. Okay. So what we know is that distance, the foci, that's the C. Foci is always your C value. So this distance from that center, because we're centering this at 0, 0, and this distance right here is 2. So that's my C value. Okay? So the other piece here that tells me, it says my minor axis has length 2. Okay. Well, the foci are always on the major axis, so we're going this way. So my minor axis has a length of 2. So the distance from the one endpoint to another endpoint has to be a distance of 2. So from here to here, so that's 0, that's to 1, down to -1, that's a distance of 2. So this would be some of my endpoints. Okay, so I know these are the foci, so those are inside, so it's got to go somewhere out here beyond that. So that's what I got to find, is I got to find, what is that A value? What is that distance of my, that my vertex would be out to? So here, my C value was 2. Okay. My minor axis has a length of 2, so this distance right here, that's the short one, so that's the B value. So I got to find out what that A value is. And again, using that formula, the Pythagorean relationship of A squared equals B squared plus C squared, A squared equals the B value, which is 1 squared, plus my C value, which is 2 squared. So A squared equals 1 plus 4. A squared equals 5. A would be plus or minus the square root of 5, which is again a little bit over 2. So that's where this would end up. And I would have my ellipse then. We'll go through there, the 1. So writing that final equation, so it's elongated in the x direction. So the a value's got to be done here. So my a squared is right there, plus y squared over the short one, which would be 1 squared, and that equals 1. That'd be the equation of my ellipse. All right, so let's keep practicing here. All right, so now we're going to look at the situation where the center is not at 0, 0. So we're looking at having that adjusted, that the center is now here at some hk, or if it's elongated in the vertical direction. Again, the center is not at 0, 0. So how do we adjust that? Well, if we were looking at this equation right here, if it was centered at 0, 0, again, it's elongated in the x direction, so the a squared value would be underneath the x because the a is always the long one. We would have had something like this. But we've adjusted this. We've moved this to the right h and up k. So just like we did with parabolas, we make a little adjustment to the x's and the y's. So this would be some x, think opposite, minus h squared plus y minus k squared. So if it was elongated in the y direction, then we'd have our x squared over over b squared plus our y squared over a squared, because the a goes, if it's elongated in the y direction, the a always goes under the bigger one. But then we got to make this adjustment for moving that center. So our equation would be this x opposite of that moving to the right h. Again, short, x is the short, the minor axis, plus y minus k squared over 8 squared equals 1. So this is really just making that adjustment. So it's not, big thing to really remember, because we've already kind of done that with parabolas in the past, and actually with all graph translations we've kind of done that, with making those moves up, down, left, or right. So let's just get into an equation or an example. So it says find the center, the vertices, and the foci of the ellipse. So center should be pretty easy. We should be able to identify that pretty quickly. So we're just looking at those adjustments that were made right here and thinking opposite. So that would be at negative 1, 1. That's where my center would be. And if you want, you can start to kind of even draw it a little bit. We also know that here the bigger numbers underneath the y, so I know this is going to be elongated in the y direction. But if you want to start drawing this, here's my center at negative 1, 1. And again, we're going to know it's longer vertically than it is horizontally. The major axis will be going vertically, minor axis will be going horizontally. So we just got to be able to find those pieces now. Okay, so again, knowing that that's the longer one, that's my a squared value, because that's 9 is bigger than 4. So my a value is plus or minus 3. Here, that's the short one, so that's the b squared. So my b value is plus or minus 2. So if I want to find out what the c value is, I'm just going to use that a squared equals b squared plus c squared relationship. And this is 9 equals, the b squared is 4 plus c squared equals 5, square root is plus or minus the square root of 5. Okay. So now remember, these different values now will help us figure out the rest of this equation. Okay, so or figure out the rest of the points that we need, because we need to find the vertices. Okay, so those vertices, we got to look at, how am I taking this in this case in the y direction, because that's underneath the y. So I got to go from this point right here, from that negative 1, 1, I've got to go up 3. 1, 2, 3. So that point there would be negative 1, 4. Okay. The next vertex, then we'd have to go down 3. So 1, 2, 3. So it'd be down here. And that piece is at negative 1, negative 2. So those are where our vertices are. Okay. If you want to try to draw the other piece here, we go plus or minus 2 to get the minor axis. So I'd go out to here. So I'd go plus 2 from there. And I'd go minus 2 from here to be able to start drawing that this ellipse. Okay. Not the best of the drawing, but that's all right. I just know that this distance is 2 and this distance is 3. So the foci then are based off of that C value. Okay? So I've got to take this. That foci is going to be somewhere right in here, somewhere right in here. So you know it's got the same x value. So it's at negative 1. And then it's going to be at this 1 value plus that root 5. And then at this 1 value minus that root 5. So you can just write this together if you want to go 1 plus root 5. And then the other one would be at negative 1 and 1 minus that root 5. Okay. With anything, we always need multiple problems for practice here. So just doing it once, I don't expect everybody to get it. So let's just try it again with another problem. So when I look at this one, again, I see a bigger number right here. So again, I know this is underneath the y. So I know it's going to be an ellipse that's elongated in the y direction, not the x direction. Okay. So knowing that this is the bigger one, again, that's my a squared value. So my a value is plus or minus 4. Okay. That's going to help me determine that major axis. Here, that's my b squared value. So b equals plus or minus 2. And again, I know that that will help me determine my minor axis. So it's a minor, and then I will say here, major. Okay. Again, I think the easiest piece to identify is the center. You have to do that anyway. And that's just the adjustments that we made right here. So my center is at that opposite of negative 3, which is 3, and opposite of negative 2, which is 2. So my center is at 3, 2. So if you want, what you could do is start graphing this and looking at where this would all be. That center is at 1, 2, 3, 1, 2. If that center is at 3, 2, and again, I know it's going this way. My major axis, I have to go up 4. 1, 2, 3, 4. And down 4. So 1, 2, 3, 4. So if I look at those, again, these are along that major axis. That's where I would find the vertices. So this point up here is at 3, and then from 3, 2, I'm going to go up 4, so that's at 3, 6. And that 3, 2, so that'd be at 3, negative 2. So all I got to do is find that those foci. And again, if you want to draw this, the minor axis would be plus or minus 2, so you'd have 2 units here to the left, 2 units here to the right. So then I'd have my ellipse like this. But if we want to find those foci that are somewhere right in here, okay, you have to find that by finding that C value. And again, that's the Pythagorean relationship. So we've got the A value. The A squared value is 16. The B squared value is 4 plus C squared. So if I subtract 4, I get 12 equals C squared. And square root both sides. So this would be the square root of 12. But again, just to review, that's square root of 4 times the square root of 3, which would be 2 root 3 if we simplify. Again, it would be plus or minus for our C value right there. So that's what I'm going to take from this point. I'm going to add 2 root 3 and subtract 2 root 3 to get those vertices. So if I add 2 root 3, somewhere right in here. So if I'm going to do that, I'm going to take that point 3 from the center, and go 2 plus 2 root 3 to get this value, and then take 3 and go 2 minus 2 root 3 to get that other foci. All right, let's do a couple more here, and then we'll turn you loose to practice on your own. So just kind of some different ways these problems will be presented to you. So this one here says find the standard form of the equation of an ellipse. Okay, so we know we got an ellipse, so that's going to be some x squared over a squared plus y squared over some b squared equals 1. And again, these a squareds and b squared values can be switched depending on which one is longer. This one tells us that the minor axis has endpoints here. Okay, so let's start drawing that. So if I'm at negative 1, 4, that's an endpoint of a minor axis, and then 5, 4. So 1, 2, 3, 4, 5, 4. All right, so that's right here. So these are the endpoints of the minor axis, which means that what we know is that the major axis has to go vertically. So if the major axis is going vertically, then I know this has to be the a squared. It has to be underneath the y. And the b squared has to be underneath the x then. Okay. Now, what we might also do from this is we can probably already find the center for this. So between negative 1, 4 and 5, 4, if I go halfway between this, I can just find the average of those two, the mean. So negative 1 plus 5 is 4, and if you divide that by 2, as though our center then should be at 2, 4. All right. So I'll just write that as a little note here. Our center should be at 2, 4. It says our major axis has a length of 8. So it has the whole length of 8, which means that the semi-major axis is 4. So half of this length of 8 is 4. So if I go 1, 2, 3, 4, that's where our major axis should end up being as one of the endpoints. If I go up 2, 3, 4, okay. Again, you don't have to worry about being perfect in the drawings. This is that major axis then has a length of 8. So that's 4 right here, and that's 4 right here. As we did this one here, we saw that that was 3 and that was 3. Well, that helps us with writing our equation. We know our center is at 2, 4. Okay? we got to make those adjustments, to those x and y values. So I'm going to go x minus 2 squared over and plus y minus 4 squared. I want that to equal 1. Okay? And then, whoops. Sorry, everybody. A little glitch happened here where it erased all the information. So we were in the middle of finishing this problem. I believe we had was x minus 2 squared plus the y minus 4 squared equals 1. And then we knew that that major axis, when we had drawn this, that we had 1, 2, 3, 4, negative 1, 4, and then 5, 4 was where that other one was. We determined the center was at 2, 4, and the major axis was 8, so we had 1, 2, 3, 4, and then down 4 here, so we had that roughly like that, where this distance was 4 and this distance was 3. So that's the short one. So 3 squared would be 9, and the y distance was the long one, so 4 squared is 16. That's how we would have our final equation in the standard form. Okay. So let's just give it another practice problem with this one over here. Okay. So looking at this problem, trying to determine what this equation would be for this. Again, we can see the center here is at negative 4, negative 2. So I know that x plus 4 squared would be on the top, plus y minus 2 squared on the top over here equals 1. So we got that part to fill in real quickly just by knowing the center. And now we're going to figure out which one is the major and which one is the minor axis. So this distance from here to here is 4. This distance from here to here is from 2 to 5. That is 3. So our major axis is going horizontally. It's going on the x direction. So that's going to be the bigger number here. So I'm going to take that 4 squared, make it 16. Here, take that 3 squared and make it 9. That's really all you have to be able to do, to be able to write that equation. All right, let's get into the more complicated equations, where once again we're going to use some of that completing the square techniques that you've learned in the past, and kind of what we did also with the parabolas. Except this time, what we're going to do is kind of group the x's together, and group the y's together, and then get the single number over to the other side. And so then we can complete the square after that. So I'm going to kind of rearrange this into 9x squared, along with its minus 18x. I like to kind of keep a little space because eventually we're going to do some completing the square here in a bit. So give it a little space, then group the y's. So I got 4y squared plus 8y, give a little space, equals 23. Because now what I'm going to do is complete the square. This is still a little plus 4 there. I should have had that. Is complete the square, but I'm going to have to do a little division, factoring here first in order to be able to do that, because I can't complete the square on something that has a leading coefficient more than 1. So I'm going to take the 9 out of this piece. I'd have x squared minus 2x. And here I'm going to take a 4, positive 4 out of each of these pieces. So I'd have y squared plus 2y, leave a little space, equals 23. Okay. So there we go. And now I'm going to complete the square on the inside of these parentheses. So half of negative 2 is negative 1 squared. It's a positive 1. So again, like I sometimes like to do is put that little in a different color. Is now here I've added 1, but really I've added 9 to this side. That's the mistake people will make. So they'll forget to distribute that. Same thing here. I'm going to complete the square here. So half of 2 is 1. 1 squared is 1. So I'm really going to add 1 in here, but really I'm adding 4. So if I add 4 to this side, I got to add 4 to that side. So now I can rewrite this because every perfect square trinomial factors into a binomial squared. That this number here is always half of that b value. Same thing here is, again, looking at every perfect square trinomial. Here it can be factored into a binomial squared. Again, this number right here is always half of that b value. Then over here we got 23 plus 9, which is 32, plus 4 is 36. So again, in solving these problems, we can't have it equal to a number other than 1, so I'm going to divide everything by 36. 9 over 36 reduces to, we've got the x minus 1 squared all over 4. 4 over 36 reduces to 9. That equals 1. So there's our equation. If I want to find the center, the vertices, and the foci, center is pretty easy. That center is at opposite. So 1, negative 1. And if we're going to find the vertices now, okay, knowing that this is the longer one, and that's my a squared value. My a value would be 3 plus or minus 3. So I'm going to add 3 and subtract 3 to this y value. So 1, if I add 3 to that, I'm at 2. If I subtract 3 from that, I'm at 1, negative 4. So those are my vertices. My foci, I'm going to have to find that c value. So again, we'll use that a squared equals the b squared plus the c squared. So I've got the a squared value, that's 9. This one was my b squared value. So b squared is 4. Subtract 4 and square root to get plus or minus square root of 5. So that foci is being, they're going to add and subtract square root of 5 to that negative 1. So that is 1, and then the negative 1 plus square root of 5, and then the negative 1 minus the square root of 5 would be the other one. So there's all the answers there. So we'll have you try guided practice number 5 on your own. Pause the video, come back and see how you have done. All right, hopefully this is the work you got. Again, grouping those x's and y's together and getting the number on the other side. Doing the perfects, completing the square. Again, making sure to distribute that piece so you add the right amount on each side. Again, dividing by this number over here to get 1. So then you'd end up with your equation of your ellipse right here. Center is pretty straightforward, opposite, opposite. Vertices, again, this is in the y direction. The bigger one is in the y direction. So you're going to get, this is the a squared value. So the a squared equals 4. So the a was plus or minus 2. So you're going to add and subtract 2 to this y value. So that's what I did right there, is added and subtracted 2 to that y value. And then the foci, you have to find that c value, which we did down here. And that's being added and subtracted to the y value from the center. So it'll be that negative 8 plus root 3 and the negative 8 minus root 3. So there you go. There's your lesson on ellipses. And do your due diligence and practice those homework problems to get even better. All right. Thank you, everybody.